So we're here at Computex, and who are you?
Rob Chandhok from Qualcomm.
So what do you do at Qualcomm?
I dabble in software, amongst other things, and we work on how to fit the hardware and the software together so that our customers can make great products.
So do you work mostly in open source?
It's a mixed bag. I mean, we do a lot of work with Microsoft on Windows Phone and now Windows RT, but we also have a lot going on with Android, and we contribute actually, and we're starting to participate in a bunch of open source stuff, including like the LLVM toolchain.
So how do you optimize software for the chip? How does it work?
It's kind of a blend. There's a couple things. One, there's kinds of stuff that's like, there's a bunch of software out there in the world that's x86 specific, and we go around and make sure it works really well on ARM. Like we did a lot of work on V8, speeding up floating point in the JavaScript compiler, and that was really, it helped every ARM vendor, not just us. And then there are bits and pieces that actually only are particular to our SoC, and then we make it so like we have a back-end rendering store for WebKit that actually uses our GPU because of the kind of GPU that we have, and it makes pinching and zooming really, really fast, and that wouldn't help anybody else because it's specific to our architecture.
So the software solutions you come up with are used by your partners only, or is kind of open some of it, or?
Well, the stuff that's reasonable to open source, we open source. I mean, we contribute a lot. Look at the check-ins for WebKit. You'll see that Qualcomm's actually our open source subsidiary, Quick, is the one that actually is you'll see on the check-ins.
So there's ICS 4.0.4 has been like a huge work for like 6 more months than that. And do you work on Ubuntu? What do you work on?
We mostly focus on things that are in commercial phones, so Ubuntu isn't a mainline thing for us.
And so there's Windows, all that Windows stuff.
There is that Windows stuff, yes.
Yeah. And so what are you going to work on in the next few months?
Next few months, personally, no. Next few months, a couple of things. You want to talk more about open source stuff, or in particular? I mean, on the open source side, one of the things you'll continue to see us being very present in WebKit. You'll see us doing more and more, I think, on LLVM. For those of you that don't know, it's a GCC replacement compiler toolchain that's really interesting. We've checked in, for example, the back end to our digital signal processor, the Hexagon, and we've upstreamed that completely, so you can actually see that in the open source tree. And our goal is actually to see LLVM get really good performance, and we're actually seeing a lot of great results right now. So my team will be working on that, the WebKit stuff, and a bunch of stuff that I can't talk about yet. The other piece is this open source peer-to-peer technology we have called Alljoyn, ALLJOYN, and you can go to alljoyn.org and actually check that out. It's a fully open source project that layers on top of either Bluetooth or Wi-Fi to do a really cool peer-to-peer SDK.
So do you upstream a lot of things back to, what do you call it, the
Everything.
Linux kernel?
Kernel.org is harder to get into for us, but we try a lot, and I think we're going to get better at it. Some of that is just having the time to actually make sure it matches the coding conventions and so forth. But it's very important upstream. We think it's participating in open source is the right thing to do, not just taking it.
So how do you balance working on S3 and S4?
Well, S3 and S4 are actually pretty similar. The thing that we've done with the families is try to make it so across multiple chips. I mean, there are many chips in the S3 family and many chips in the S4 family. So we have families of compatibility, as it were, where we keep similar GPUs, similar memory processors and interfaces and so forth.
So do you have to spend as much work on each of these processors, or how do you organize it?
I would say that over time it's getting better and better because our architectures are settling down a little bit more. I'm sure things will change at the lowest level of the driver, but the upper layer parts of the OS can be more and more confident that it will change less.
Could you talk a little bit about the S4? Which parts of it are you really excited about optimizing stuff for?
Well, I'd say that I'm really excited about the performance of several parts. Of course, we optimize for the whole thing. One is clearly the dual-core crate processors that are in there, so that's our latest ARM processors, and they just are really working well, and they're really working well at a great sort of balance between power and performance. I mean, one of the things we always focus on as a design point is the mobile design case. So if you're carrying around a Snapdragon-powered device, it's going to last, that battery is going to last. The other thing that's really cool about the S4 chip that's coming out right now is the built-in multi-mode LTE. So it's not only is it LTE, but it's LTE, UMTS, CDMA, all the way down to the earlier modem technologies, because really when you're moving around in the real world you have to be able to deal with all those modem technologies, so it's really important for us. And then finally the The S4s have the first of our integrated Wi-Fis that are going to be 11AC compliant when the standard for 11AC finally finishes. And we're pretty excited about the kind of user experience you can get driving multiple streams of HD video over Wi-Fi.
So when you say you optimize V8, does that mean the part of Chrome that was not optimized for ARM at all before you start working on it, or?
Yeah, I mean, when we first started working on it, very little of it had been optimized for ARM, but a lot of people have been thinking about. But things that we work on, like we helped speed up floating point on ARM in JavaScript, and it's something that benefited everybody in the ARM community.
Is that hard float? Is it related to that?
Don't remember. Don't know the technical details at that level. I know that the way we did is we used a little bit of the SIMD processing engine that's on the side of most ARM processors, and then did a couple other tricks, and we got a lot of floating point speed up.
So could you talk a little bit about what Windows 8, or should I say RT, brings to the table? Is it secure boot, for example, and is there a lot of?
That's kind of like saying, did BlackBerry bring to the mobile space secure boot? I don't think that's the only feature. That's just one feature. I think the real thing Windows RT is bringing is, first of all, it's bringing Windows to the ARM family, and with that it means new form factors that you couldn't get out of x86. So I do an x86 design, I have to use a fan. I use an ARM design, I can do something really thin, really light, battery that lasts a real long time, but you get this really great performance, and we're going to be demonstrating Windows RT for the first time running on our processors here at Computex.
So I was trying it before, it looked really smooth. Is there a huge, amazing work behind making it smooth?
Yeah. It's been a lot of work. I mean, for Qualcomm, for example, we just brought up a fully clean DX stack instead of OpenGL, and it's working really well. And Microsoft has spent a ton of time optimizing for ARM.
All right, so it's going to work.
I think so.
But how about these desktop apps? Do you think, in theory, it should be able to? I mean, of course, it's Microsoft to answer this question, right? But why would they say that there will be less desktop apps on ARM compared to x86?
Well, first of all, they're trying to drive a particular user experience, which is the Metro experience. So one of the big differences between Windows 8 and Windows 7 is this mode called Connected Standby. So in earlier versions of Windows, drivers, applications, background processes could interrupt the CPU at any time because you're used to being plugged into a wall, in all honesty. You want to be able to put the processor into sleep like you do in a mobile device, like a Snapdragon Tower device and other operating systems. You have to sort of get there to be a programming convention where that works, and that's Connected Standby in Windows. Well, only Metro applications implemented for the user experience conform to that contract with the kernel where they actually will go into this Connected Standby mode. So you can run these legacy desktop apps if you want to. There is a desktop mode even on Windows RT, but you won't get that Connected Standby experience. So I think that all application developers are moving forward are going to really conform to Metro because users are going to demand it. They're going to say, I don't want my battery to run down. I want to use this version of the application. It's beautiful, it's touch forward, and it's something that I prefer to use. They've put all this time into the user experience. I don't think people are going to want to go backwards.
So to make real Windows work on ARM, they had to take off all the kind of bloat, right? And that's something they do with x86, but for ARM it would be impossible to make it run if they didn't really slim it down and optimize everything.
I don't know. I have a problem saying that because you're kind of implying that ARM isn't as computationally powerful as x86, and I don't believe that. We pick different design points. We don't have a processor, for example, that is designed to be as fast as possible and not care about power. It's just not what we do, right? So if you compare those processors coming from other vendors, when they're unplugged, you can see the design points we picked are really interesting. So whether or not there's bloat in Windows, which I'm not saying that there is, it isn't having to do with instruction set.
Do you think, in theory, it could dual boot Android and Windows? I mean, that's, of course, I don't know.
Everything is technically possible. Right? Everything in computer science can be solved with 2 loops and some recursion.
But the same hardware, in theory, should be able to run both, right?
I think it's been shown that in the past.
All right, cool.